Good morning. Okay. So there's actually going to be two warm-up problems. There's going to be this one. We'll talk about it. And I'm going to give you another one, and then we'll get into today's lesson. Okay. So let's warm it up, Chris. About to. Warm it up, Chris. So if my arc length is 20 Smarties long, and the radius is 10 Smarties long, what is the measure of this central angle in here? We'll call it theta. Anybody? We got Luke?
I have 114.59.
Do we agree with 114.59? It should be a nice, easy number. But I think what you did is you converted it into degrees.
Oh, it should just be 2.
To what?
2 radians.
2 radians. Two radians. Okay? Because remember, a radian is an arc length, or I should say, it's the angle measure that makes the arc length, that makes it be the same distance as the radius. Okay? So if my radius is 10, my arc length is 20, that means that I had to have a 2 radian angle measure. Okay? Now, if I would have converted this to, let's say, 4 Smarties, now how much, or what's my central angle? 5 radians, right? Okay? So that's that angle measure, and we'll get more into that next week. But how theta, my angle, is equal to r times the arc length is theta times the radius. Okay? So, kind of an offshoot of that, if my central angle is 1.5 radians, and my radius is 8, what is my arc length? 12, because 12 is 8 times 1.5. Because we went 1.5 radians. Okay? So 1 radian would be 8, half of a radian would be 4, so we went 12 units in this particular case. Okay? All right? Wanted to get you thinking back about the Smarties and all that fun stuff that we had. Okay? The main goal for today is actually what you just did on the first warm-up problem, Luke, was we want to convert angles today. So we want to work on converting from radians to degrees and degrees to radians. Okay? What we need to remember is that there are 2 pi radians in a 360-degree circle. Okay? So the way that we do this is we do this with a factor label method. So that factor label method, remember, is if I have 6 feet and I want to convert that into inches, okay? Truly what I'm doing, you probably will just multiply by 12 because there's 12 inches in 1 foot, okay? But truly what you're doing is you're saying, okay, there are 12 inches in 1 foot, so I am factoring out the labels. This purple fraction is equal to 1, because 12 inches is 1 foot. Okay? So that's equal to 1. So I can still multiply by it. When I multiply by 1, it doesn't change the value. Okay? And so then when we multiply across, then we get 72 inches. Okay? Done that. You've probably done that in science numerous times. Later on next week, we're going to use the factor label method a ton once we get into circular motion type problems and converting between angular measure, angular, linear, and distance. Okay? So, all right. 4 quarts in a gallon. So we've got 32 quarts. We said that there's 4 quarts. No, is it 4? No. 8 quarts in a gallon? I think 4. 4 quarts. The quarts cancel off. 32 times 1 is 32 divided by 4 is 8. Yeah, probably go look right here. Right? So how we do that in terms of angles and radians and degrees is the conversion is if I'm switching to, it all really is depends on what you want on top. So if we've got 2 pi radians, oops, I put the R in the wrong spot. If we've got 2 pi radians over 360 degrees, that would be the same as pi radians over 180 degrees. So if I wanted to get rid of degrees, I would multiply by that fraction, because that blue fraction is equivalent to 1. I could also invert or reciprocate that fraction. So that green fraction is also equivalent to 1. And so what we can do with that is that would cancel out the blue fraction would cancel out degrees. The green fraction would cancel out radians. Okay? Or factor label the radians. So if I want to convert 90 degrees into radians, I would start with my 90 degrees. That's the label that I want to get rid of. So I am going to multiply by, oops, this one was my blue one. Sorry, wrong color. So I'm going to multiply by pi radians over 180 degrees. And the label that cancels out now is the degrees. And so then what we do is classically, in terms of radians, unless it says differently in the directions where it might say round to this decimal place, we like them in fraction form. So 90 pi here over 180 would reduce all the way down to pi over 2. Because the fraction 90 over 80 is not. We would just, whenever we see the pi, we assume that it's radians. Okay? Yeah. But you could also put the little r up there if you wanted. Yes. But if we see, for sure, if we see pi, we know we're talking. So we don't necessarily like that little r symbol. Not necessary for us. Okay? So with that being said, convert me 315 degrees and 210 degrees. let's see, 315, can that be divided by 5? Well, yeah. What is that? 63? Over 18 would be 36. Divide both by 9. Agree with 7 pi over 4. Okay. Divide both by 10. Actually, we can divide both here by 30. If I divide by 30, then I got 7 pi over 6. Yes? Okay. Good times. Converting the other way now. Okay. So when we convert the other way, now instead of multiplying by pi over 180, I'm going to multiply by 180 degrees over pi radians. And we're going to assume that there's radians there. Cancel, cancel. Okay. Pi's cancel each other out. 180 divided by 6. 30. Okay. 9 pi over 2 times 180 over pi. The pi's will cancel each other out. The 2 goes into 180 90 times. 9 times 90 is 810 degrees. Pretty warm. Okay. On these two, so we can just start with 3, and we do it the same way. Times 180 over pi degrees. Radians cancel each other out. Leaves me with 540 over pi degrees. If I was asking for an exact answer, it would be that. Okay. If we want it rounded, then that would be 171.887. Because we would literally type in our calculator 540 divided by pi. Okay. We would do the same thing with 1 radian. So that's going to be 180 divided by pi degrees, which is also what we learned on Wednesday, 57.296 degrees. Yeah. Now, there's some other degree measures out there. Okay? There are 2 other forms of degree measures. One is called decimal degree. Okay? And decimal degree is just like these last 2 that we did. That's a decimal degree. It's a degree that's got a decimal attached to it. I know we stepped way outside of our comfort zone when we named decimal degree. Okay? Right? It's just that. Okay? The other one that we have is called DMS. And DMS stands for degrees, minutes, and seconds. Okay? And converting back and forth between those two, so this would be like a decimal degree, and this one down here, there it is, would be a degree, minutes, and seconds. Okay? So 1 degree is 1/360th of a circle. Would you all agree with that? 360 degrees all the way around the circle. So 1 degree is 1/360th of that. 1 minute is 1/60th of a degree. Okay. So this one here is minute. Move this over. I wonder if it moves. The whole thing moves. Of course it does. Yeah. And 1 second is 1/60th of a minute. So if there's 60 seconds in a minute, and there's 60 minutes in a degree, that means that 3,600 seconds is equal to 1 degree. Okay. So here's how you would convert from degrees, minutes, seconds, which these two, I think there's only two, yep, so these two would be degrees, minutes, and seconds. Okay. How we convert that into decimal degrees, what we're normally used to. I don't know why it's jumping today. Okay. So first off, you take the degree part, and you just start with that. Okay. So you gotta have 245 degrees, it's gonna be 245 degrees. Okay. Then you take the minutes part. So I've got 10 minutes. Well, 10 minutes is 10/60ths of a degree. Now they're in the same unit. Okay? Because if 1 minute is 1/60th of a degree, then 10 minutes is 10/60ths of a degree. Okay? Now we go to a calculator, and we say that that then is 245.167 degrees. Really, it's 0.166666666666666666, and so on. The 6. Okay. And that's it. When we get down here into one that has a degrees, minutes, and seconds, so we start with the degree. Then we do the minute. Now here is where you're going to make your mistake. Every time. I've seen it every year. Okay? What do you want to divide 25 by? heard 60, and I've heard what? And I've heard 360. Neither one is right.
3,600.
3,600. Because way back up here, remember, so now this black 148, that's in degrees. This green 16/60ths, that's in degrees. Remember up here that 3,600 seconds is 1 degree. So if I want to get them into the same units, I would have to add 25 over 3,600. The most common mistake there is just dividing the 25 by 60. Okay? So when you type all of that into your calculator, you should get 148.274-ish degrees. Yes? Love it. Good times. Okay. Going the other way now is actually a lot easier. Okay? Because here's what you do. 345.12 degrees, well, 345 is going to be 345, right? Okay? So my answer over here is going to be 345 degrees. Oops, I put 354. Come on, Linsmeyer, you're better than that. So jazzed up about changing over to degrees, minutes, seconds. Okay? Then what you're going to do is you're going to take this part right here, this decimal, 0.12, and you're going to multiply that by 60. 0.12 times 60 is 7.2. So this 7 then, that whole number in front of the decimal point, that is your minutes. Then you take the decimal point again, 0.2, and multiply it by 60 again. 0.2 times 60? 12. So then there's 12 seconds. Now, if it doesn't work out perfectly, because we're only going to degrees, minutes, and seconds, we would round the seconds to a tenth, to 1 decimal place. Okay? Because that's so far out on the quote unquote sig figs or rounding that we're good there by rounding that one to a tenth. Okay? You try number 4. It would be our last example of. Wait, maybe what's the shade down here? Is there? I was going to say there's not more. We'll try this one. It will be the last example of the day. 215 is 215. 0.63 times 60 is going to be 37.8. 0.8 times 60 is going to be 48. So this becomes 215 degrees, 37 minutes, 48 seconds. Yes? Good times.